This is lesson 9, when are they the same? And this is activity 3, elevators. And there are 2 elevators in this activity. And one of the questions is, when are they at the same height as they travel up and down, as they move up and down? So here are the 2 elevators, and the authors give you 2 expressions. So elevator A reaches height h, whatever this height is, in this amount of time. So you take 8/10 times whatever the given height is, you add 16 to that, and that gives you the total amount of time that it took that elevator to travel to that height. Elevator B is the same idea, so it's a negative 8/10 times the height plus these 12 seconds. That gives you the total amount of time it takes to travel to whatever this given height is. Now, one issue is what is the 16? What is the 8/10? This is height. So what's the 12 here, and what's the negative 8/10 here? And one thing to understand is that this term is seconds, a number of seconds. And this is number of seconds, it's 16 seconds. So 8/10 times the height gives you an amount of time, and you add that to the 16 seconds, that gives you the total time. And the negative 8/10 times the height gives you an amount of time, and you add that amount of time to 12 to get the total time that it takes elevator B to move. So this is seconds, and this is seconds. So you have to add seconds plus seconds to get total time. Seconds plus seconds to get total time. And the way that this term right here becomes seconds is that this is 8/10 seconds per meter. So 8/10 seconds per meter times the number of meters gives you the total amount of time that it traveled. Same down here. It's a negative 8/10 seconds per meter times the total number of meters gives you the total amount of time that this elevator traveled. Now, if you look at these 2 elevators, this elevator is going down, and so to get to a positive height, so 1 meter, 2 meters, 3 meters, it's going to take less time than it takes for this elevator to get to ground level. On the other hand, for this elevator to get to 1 meter, 2 meters, 3 meters above ground, it's going to take more time than it takes this elevator to get to ground level. On the other hand, for this elevator to get below ground level, it's going to take more time than what it takes to get to the ground level here. In this elevator, to get to levels that are below ground, it's going to take less time. So let's see which of these 2 expressions fit which of these 2 elevators, just for a moment. So if this is at 1 meter, so a height of 1 meter, this is going to be a positive value. It's going to be 8/10. So that's going to be 8/10 seconds gets added to 16 seconds. So that's going to be more time than what it takes to get to a height of 0. A height of 0 is going to take 16 seconds. When height is 0, 0 times 8/10 is 0, it's going to take 16 seconds. So if the height is 1 meter, it's going to take more time than that. So if the height is 1 meter, it's going to take more time than that 16 seconds to get to that 1 meter. So this has to be elevator A. Elevator A is going up, and this is elevator B is going down. Let's see if the same idea holds. If this is 1 meter, this is going to be a negative 8/10, because 1 times a negative 8/10 is a negative 8/10. So you add a negative 8/10 to 12, that's less time. That's 11 2/10. So it takes, to get to 0 height, to get to ground level, it takes 12 seconds, because when h is 0, this takes 12 seconds. But to get to 1 meter, it takes only 11 2/10 seconds. So that makes sense. To get to 1 meter, it's going to take less time, 11 2/10 seconds. If it's a negative 1 meter, then this is going to be a positive 8/10. A negative 8/10 times negative 1 is a positive 8/10. So it's going to take 12 8/10 seconds to get to 1 meter below ground. So it's going to take more than 12 seconds to get below ground. If this is a negative 1, this is going to become a negative 8/10. So this would be 15 2/10 seconds. So less time to get to 1 meter below ground. So it makes sense. This elevator is going up. To reach these levels, it takes less time than it takes to get to ground level. and it takes more time than it takes to get to ground level to reach these heights above ground. This is the opposite. To get to these heights, it takes less time than to get to ground level, and to get to heights below ground, it takes more time than to get to ground level. Pretty hard to talk through, pretty hard to understand. I wanted to go to graphing these problems, and I really started to run into problems because these expressions are written in terms of height. So we'll talk about that as we go through this. But first, let's just answer these questions. I did rewrite the problem in terms of time. So the language that we use is both of these equations. If this is time equals this amount for elevator A, and this is time equals this amount for elevator B, they are written in terms of height. So you would graph the height on the x-axis or horizontal axis, whereas I rewrote each equation in terms of time. So height is equal to this expression for elevator B, and in elevator A, height is equal to this expression. And so these are written in terms of time. So now in this case, time would be graphed on the horizontal axis, and height would be on the vertical axis. This is much easier for me to explain as we look at the graphs. So we'll get there. It's actually a bit easier for me to answer question 2, which says, how long would it take each elevator to reach ground level at this time? And that time is time 0. That's the time when you walk up to the elevators. And this question really is asking after this time, not at this time, but how long. So you walk up to the elevators, press the button. How long does it take each elevator, or how long does each elevator take to reach the ground floor? So you're standing there. How long is it going to be before that elevator, those elevator doors open? So for elevator A, how long does it take to get to height 0? So height is 0. The time that it takes, you have to add these 16 seconds here. And we'll get to that. There's a little drawing I'm going to show you soon, and we'll get to what that 16 seconds means. But you're traveling at 0.8 of a second per meter for 0 meters. So how long does that take? Well, that takes 0 time. You haven't gone anywhere. It takes 0 time. Then you have to add these 16 seconds. So the total amount of time it takes for elevator A to reach the ground floor is that 16 seconds. Elevator B, similar case, but elevator B is going down. So it's a negative 0.8 seconds per meter times 0 meters. So how long has it taken to go 0 meters? Well, it's taken 0 time once again, but you also have to add these 12 seconds. So it takes elevator B 12 seconds to reach the ground floor. So elevator A is going up, and we're going to figure out what that height is that it's going up in just a moment, and elevator B is going down. So we'll figure out how far it's going down. That is question number 1. So now we know the time. So now question number 1 says, what is the height of each elevator at this time? So that's correct now. So you walk up to the elevator at that time that you walk up. Where is that elevator located? At what height? Well, elevator A at time 0. So now you make the time out here on the left 0, and that's equal to 0.8 the height plus 16. So notice that at some point in time, this height, whatever this height is, we're going to see that that's negative 20 meters in just a second, but that height is equal to negative 16 seconds. And it has bothered me for a long time. What is that negative 16 seconds? What does that mean? Because you have to figure out how to make this term right here negative 16 and add this to a positive 16, and that equals time 0. And so what's going on? What's the 16 seconds here? We know that's how long it takes the elevator to get to ground level. We just figured that out. But what's this negative 16 here? So I made a little diagram. And so we're going to just look at elevator A for just a second. That's the red. That's this elevator. So at some point in time before you show up, so this is time along the horizontal axis, and this is the height along the vertical axis. So at some time before you show up, so this is time 0 right here, so you have to go backwards in time. This elevator, now we're going to figure out that it's at negative 20 meters, but this elevator was at ground level before you showed up. And then it took 16 seconds to reach its height, which is a negative 20 meters. So it takes that 16 seconds to go down to, let's call that the 4th floor below ground. So each floor is 5 meters. So this is 4 floors. This up here, 15 meters, would be 3 floors. So it takes 16 seconds to travel down to 4 floors, down to negative 20 meters. And this is the positive 16 right here. So now after you show up, it takes that same 16 seconds now to get back to ground level. So it starts at ground level before you show up. At some point in time before you show up, it took 16 seconds to travel from ground level to negative 20 meters. Now it could sit here at negative 20 meters for a couple hours. Then finally you walk up, press the button, and then it takes that same 16 seconds to reach you at ground level. So this negative 16 seconds here is the time before you show up, and it takes this elevator to reach this negative 20 meters. So you figure out the height. That height is a negative 20 meters. So it takes 16 seconds before you show up to reach negative 20 meters, and then it takes a positive 16 seconds to reach 0 height to reach ground level after you show up. Same with elevator B. So you go through this calculation, and what's this negative 12 right here? Now remember, this is it's going in the opposite direction. This is going down. So it's a negative 8/10 seconds per meter, or negative 8/10 seconds per, 8/10 seconds per negative meter. So it's actually going down. So at some point in time, 12 seconds before you showed up, it had to have been at 15 meters. This has to equal negative 12. Well, negative 8/10 times what height equals negative 12? That's 15 meters. That's the answer down here. But in the drawing, at some point in time, at least 12 seconds before you show up, this elevator is at ground level. Then it took 12 seconds to get 15 meters high, which is 3 stories, go up 3 stories, and now it's going to take that same 12 seconds to travel down to you at ground level. So from 15 meters down to ground level, it's going to take that 12 seconds. So this is added 12 seconds here. This is how much time it takes to get to you after time 0, but it's a negative 12 seconds to get from ground level to that 15 meters up in the air. So you go through the arithmetic and you figure out at time 0, the height of the elevator is 15 meters. Now, I struggled with this for a long time, and I went back and forth, a bunch of different drawings. I like this drawing. I think this kind of makes it clear to me what's going on, but the drawing that I like a little bit better, but let me just take a moment and tell you what's going on here. This is just showing you that this elevator is moving down at the same rate that this elevator is moving up. So this is a negative 8/10 seconds per meter. So this is a negative 15 meters. So it's going down 15 meters for 12 seconds. You go out here 12 seconds, and it goes down 15 meters. That's a negative 15 meters per those 12 seconds. So you do the calculation, that turns out to be a negative 10/8, or actually a negative 5/4 meters per second, but I'm going to leave it as 10/8, because then you use the reciprocal of that. You want seconds per meter. Now, dealing with these units is going to take a long time to understand and get comfortable with. Not sure where in the curriculum they're going to give you that much practice, but this is hard. This is figuring out how these units change throughout a problem can be a difficult task. But a negative 10/8 meters per second is the same as a negative 8/10 seconds per meter. So we could act that out. You travel a meter, that takes 8/10 of a second, or you travel for 1 second, that's going to be more than a meter. That's going to be this 10/8. But anyway, the point is that this is going down at a negative 8/10 seconds per meter, and this elevator is going up at a same rate, but in the opposite direction. So a positive 8/10 seconds per meter. Now, a drawing I like a little bit better is this drawing right here. So this is the same equation at time 0. What height is the elevator? And we figured out it's negative 20 meters. So at time 0, before that time, it had to have been at ground level. So if I'm at negative 20 meters, I'm going to go backwards in time to get to the ground level. And so now I'm going to go from ground level to negative 20 meters. And this is that negative 16 seconds before you show up. And so now at negative 20 meters, the elevator is both 20 meters away from you. It's at negative 20 meters, and it's 16 seconds away from you. So it's going to take this 16 seconds to get back to you at ground level. That's this 16 seconds right here. And this negative 16 seconds is where it's going from ground level to negative 20 meters. Similar case for elevator B. Elevator B is at ground level at some time before you show up. It's at ground level. Well, it has to go backwards in time. If you think about it backwards in time, it's 15 meters. It's going to go backwards in time to ground level. That's going to take this 12 seconds. That's a negative 12 seconds. It's time before you show up at the elevators. And so now you show up at the elevators. Where is it? Well, it's that elevator is both 15 meters away from you, but it's above ground 15 meters, and it's also 12 seconds away from you. So it's going to take 12 seconds to go down that 15 meters to get to you at ground level. This is tough stuff. Now, we could just work with the equations, plug in the numbers, and say, oh, gee, here are the answers. But it really takes some effort to kind of figure out carefully what's going on with the elevators. All right, so question 3. If the two elevators travel towards one another, at what height do they pass each other, and how long will it take? So these two elevators are traveling towards each other. At what height do they pass each other, and how long will it take? Well, this is the height right here. This elevator, remember, they're traveling at the same rate in opposite directions. That's important because then you can just look at where these lines intersect, and it's a equal amount of time that it takes to get to this point from 15 meters, and it's that same amount of time it takes to get from negative 20 meters to that same point right here. So this elevator is going down, 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 down. It takes 12 seconds to get the ground level, but this elevator at 12 seconds has not reached ground level yet. It's still below ground. This elevator is going to continue past ground level to below ground. This elevator is going to continue up to reach ground level, but they're at the same height before, actually below ground. And so how long does that take? That's this value right here. So 14 seconds. We're going to figure out that this is a negative 2.5 meters. So it has 4 more seconds to go from 12 seconds to 16 seconds. 4 more seconds to go to get to ground level. And we're going to figure out that that's 5 meters. So this is half that distance. This is 2.5 meters. So it's at a negative 2.5 meters. It takes 14 seconds. So let's do some math to figure that out. So if you set these two equations equal to each other, this is the time for elevator A, and this is the time for elevator B. So when are both of those times equal to each other? At what height is this time equal to this time? So height is the same. So at what height does it make these two times equal? Well, that height is, so you do a little bit of algebra here. So this is Going to add going to add a positive 8/10 h to both sides. This is going to make this 1 6/10 times the height plus 16 equals 12. These are the seconds here. And so now you add a negative 16 to get rid of that 16. So this becomes negative 4. And so this is 16/10. I'm going to change this to a fraction because it's easier to work with as a fraction. To get rid of this coefficient, I'm going to multiply by the multiplicative inverse, 10/16. So that gets rid of it on this side. This is the 10/16 times negative 4. And so this is fairly easy to multiply. You can factor 16 into 4 times 4. This is a negative. This whole term is going to become negative now. This is a negative because it's negative 1 here or negative here. So a negative 4 times 10 divided by 4 times 4. Well, the 4 divided by 4 is 1. 10 divided by 4 is 10/4, which is the same as 2 1/2, or negative 2 5/10 meters. So the height at which they pass each other is a negative 2.5 meters. And how long does it take to get there? Well, this is the height now that you use in the calculation for time. How long does it take this elevator to get to negative 2.5 meters? It takes 14 seconds. So this is this height, negative 2.5 times 8/10. You're going to calculate that as, and if you think about 8/10, what's 8/10 of a negative 2.5? Well, 8/10 of a negative 2.5 is 2. So this is a negative 2 plus 16. So it's 2 seconds before it reaches ground level. So 2 seconds before it reaches ground level, that's 14 seconds. This is 2 seconds after elevator B reaches ground level. So it's continuing down 2 seconds after it reaches ground level. So that's 14 seconds. We'll go back to this drawing. Here's the 14 seconds right here. This is 2 seconds after this reaches ground level. Well, in 2 seconds, it travels 8/10 of a second per meter. So this is 2 seconds. No, actually, it's really 10/8 meters per second. So this is 2 seconds. So it's going to actually be 2 times this 10/8. And you get to a negative 2.5 meters in 2 seconds. And then it takes this travels up another 2.5 meters to get to ground level. It takes another 2 seconds. Sorry about that, messed this up a little bit, but hopefully the drawing begins to make sense as you think about these numbers. All right, so this is a pretty interesting question. If you're not at ground level, let's say that you're at a parking level that's 14 meters below ground level. Which elevator would reach you first, elevator A or elevator B? Let's go to this drawing for just a second. Notice that you're now at 14 meters below ground level. So elevator A has to go from negative 20 meters to negative 14 meters. Well, how far is that? That is 6 meters. And how long does it take this elevator to travel 6 meters? It's traveling at 8/10 of a second per meter times 6 meters. 6 times this 8/10 right here. This is going to take 4 8/10 seconds. 6 times 8 is 48. 6 times 8/10 is 4 8/10. This is going to take 4 8/10 seconds to get to here. So let's look at that calculation first. So the height is a negative 14 meters. So it's 8/10 times a negative 14 meters. And you have to add these. This is 16 seconds here. So now it's going to travel 8/10 of a second per meter times a negative 14 meters. So how many seconds is that? It takes 11 2/10 seconds, but it's going in the opposite direction. It's going up for 11 2/10 seconds. So this is a negative 11 2/10 seconds and you have to add that to the 16 seconds, and so you end up with this 14 and 8/10 seconds. And that's pretty tough. So let's see what's going on here. It's almost as if this elevator takes, if it's at 14 and negative 14 meters, it's going to take 11 and 2/10 seconds to reach ground level. But you don't have to go that far. So you can actually subtract that time, that 11 and 2/10 seconds, from the 16 seconds it would normally take you, and you're left with the 4 and 8/10 seconds it takes to get from negative 20 meters to a negative 14 meters right here. So you can subtract this part. So you go back to the equation. That's this negative 11 and 2/10 seconds. Now over here, negative 14 meters times a negative 8/10 seconds per meter. So if you multiply negative 8/10 seconds per meter times a negative 14 meters, you're going to get a positive 11 and 2/10 seconds. So this elevator, notice, this elevator takes 12 seconds to travel 15 meters. So here's 15 meters, it takes 12 seconds. And to get to negative 14 meters, that's another almost 12 seconds. 14 meters is just 1 meter less than 15. So if it were 15 meters, it'd take another 12 seconds to get to negative 15 meters. It doesn't have to go that far. It only has to go to negative 14. So this is that 11 and 2/10 seconds right here. But that gets added on, not subtracted, but added on to the 12 seconds it already has to travel from this 15 meters. So you can see that this takes a very long time for the elevator to get to negative 14 meters compared to elevator A. So this is 11 and 2/10 seconds plus 12 seconds for a total of 23 and 2/10 seconds.